Okay, hello everyone and welcome. Guys, today we're going to look at systems of linear inequalities. We've been looking at linear inequalities, but now we're going to look at two inequalities put together, all right, working together. All right, our objective for today, guys, to graph and identify the solution to a system of linear inequalities. All right, you guys did systems of linear equations last year. Now we're going to do inequalities. All right, the essential question. Let me slide this up a little so I can get my face in here. Guys, how do we identify the solution to a system of linear inequalities? All right, that's today's essential question. Guys, just a review of linear equations. Guys, remember linear equations? You had them last year. You had two linear equations. All right, we graphed them. They look like this. We had two lines. And the solution to the system was where the graphs intersect, was where those two lines intersect. It's the point that both of these equations have in common. It's the xy coordinate that will make both of these equations true. All right, that's a system of linear equations. Also, guys, remember a linear inequality, it's just like a linear equation, except it has an inequality sign, instead of an equal sign. Okay, so you have greater than, less than, greater than, equal to, less than, equal to. All right, those are inequality symbols or inequality signs. Guys, a linear inequality, again, it looks like this. This means y greater than 2x minus 3. You graph the line y equals 2x minus 3. All right, but this one is a dotted line because it's not included in the solution. It just says y greater than. So you shade above the line, y greater than, okay? Guys, now we're going to look at a system of linear inequalities. And then they look like this. Again, it's just two inequalities. All right? When you graph them, they look like this. These are two inequalities we're graphing. But they overlap. The two shaded areas overlap. See this darker shaded area here? All right, any point that's in this overlapping shaded area is a solution to this systems of linear inequalities. Okay, there's a whole bunch of points that will make both of those true. All right? Again, you just graph each one individually, shade both areas, and see where the shaded areas overlap. All right, guys, there are certain ways to graph inequalities. In slope-intercept form, they're pretty easy. All right, we've done quite a bit of that. Also, if it's in standard form, you can use the cover-up method and then test a point to see which way to shade. Or you can use Desmos. Those are ways to graph inequalities. Guys, there's four things to remember about systems of inequalities. All right, a systems of inequalities, it's two inequalities working together, just like a systems of equations. All right, they work together. All right, the solution to the system is the intersection of the solutions to the two individual inequalities. The intersection of those two solutions is the solution to the system. All right, again, the solution is the overlapping shaded area, and any point in this double shaded area will make both inequalities true. All right, that's the solution. Makes both inequalities true, okay? As an example, here's the systems of linear inequalities. First thing you do is graph this top one here. All right? We got it right here. That's y less than 2x plus 1. Again, the line is dotted, and we shade below. All right, then you graph the next one. Again, this is in standard form. You can use the intercepts or switch it to slope-intercept form. All right, and this is graphed shaded below because the y here is negative, so the sign flips around. As the last thing you do is you see where the shaded areas overlap. It's down here in this darker purple part. Not the red part or the blue part. This dark purple part down here. Any point, any ordered pair, any xy point in that double shaded area will make both of these inequalities true. Okay? Guys, that's it. Please complete the homework check and get ready for tomorrow. All right, thanks.